not sure. We're not really doing anything new, and I already finished my homework for tonight. Class today.
What kind of stuff are you working on? What's
we're working on like these really more complicated equations, inverse equations.
Okay.
With exponents in both numerator and denominator, stuff like that.
Okay. But not, you're out of statistics, you're out of probability.
Yeah.
You're just doing complex algebra.
Yeah.
Okay. You doing all right on it?
Yeah, it's not too hard.
Yeah? Yeah, you're pretty good in algebra. So I would think that it wouldn't be too hard. In other words, if you can do this problem right here, you can do any algebra problem.
Mm-hmm.
It's a question of finding the common denominator, making sure that this fraction is the same with that common denominator, and then operating on it. So even if they give you a problem, and I've seen these kind of problems where you have something like this, something where you have a lot of nested stuff. That's what I call that, is nested.
Well, I think it was more, what I was more talking about is like graphing, like, so if you had like x squared plus 4x plus 4 over x squared plus 8, you graphing those.
All right.
That's more what we're working on right now.
Whenever you're graphing a rational quotient, which is a polynomial divided by another polynomial, the first thing is to recognize that it's going to be hyperbolic in nature. In other words, it's going to look something like that. Okay?
Mm-hmm.
Now, it's going to have a different grid. And the grid is going to be determined by the vertical asymptotes and the the horizontal asymptotes. I'm going to change that problem just a little bit to make it look like that. It's a much better problem now. Where's my vertical well, first of all, what should I do with this?
Find your x-intercepts and your two asymptotes.
When you see a quadratic in the numerator and a quadratic in the denominator, factor. So what's the top factor into?
X plus 2 squared. X plus 2 and x plus 2.
What's the bottom factor into?
X plus 2, x minus 2.
Now notice that because we can cancel, this whole thing turns into x plus 2 over x minus 2. With one exception. And that is x can still not be equal to minus 2. In other words, just because I canceled those does not take away that domain restriction. X certainly cannot be equal to 2 because I would be dividing by 0 in the final equation. But x also cannot be equal to minus 2 because that would be 0. And I still cannot divide by 0. And that results in what is called a hole. Okay? So if I was going to graph that equation, far right, I would see a vertical asymptote at x equal 2, right?
Mm-hmm.
Where's the horizontal asymptote?
X minus 2.
Take the highest power of the variable in the numerator, the highest power of the variable in the denominator. If they are the same power, it's the ratio of their coefficients. What's the ratio of the coefficients?
1.
So y equals 1 is where the horizontal asymptote is. It's always the ratio of the coefficients, whether I start from there or my final answer. It's still 1. Now, I know what hyperbolic functions look like. There's only 2 ways this function's going to look. Like that, or maybe it'll be in the second and fourth quadrant. I'm not sure which yet. Our original function, I believe, was x plus 2 over x minus 2, correct?
Mm-hmm.
How can I tell whether it's my black line or my red line?
It's black line because the coefficient A is
Not
positive.
necessarily. Not necessarily. The best way to tell, the only way I've ever found to tell,
Plot points.
plug in a value for x that is to the right of 2.
Okay.
So what's a good value for x?
3.
Okay. So when x is 3, y is 5. Am I on the black line or am I on the red line?
On the black line.
Absolutely. So I can erase the red. There's my curve. Now, if my life depended on it, I might be inclined to put in a number of x equal 1. Well, that would give me 3 minus 3. So when x equals 1, am I way down here? Yes, I am. So I know I'm right now.
Mm-hmm.
And that's the best way to do it. It's frequently very, I got one other restriction here. And that's x cannot be equal to minus 2. What that results in is a hole right there. Does not result in a vertical asymptote. It just results in a hole. Notice that if I go back to my original equation, x equal minus 2 gives me a denominator of 0. So x can never be equal to minus 2 and x can never be equal to plus 2. The plus 2 is taken care of by my vertical asymptote. But the minus 2, that kind of got factored away, but did not disappear. We still can never have x equal to minus 2. Impossible. That causes division by 0. So that's what this graph looks like. In other words, the way to draw all of these rational quotient graphs is to draw your grid. Figure out where your vertical asymptotes are, figure out where your horizontal asymptotes are, and then know you're either in the first and third or the second and fourth quadrant. It's that simple. And then if you need to put holes in there, do so after the fact. Don't forget. In other words, it's true that this function reduces to that x plus 2 over x minus 2, but it does not change the fact that x cannot be equal. In other words, it's this function with the provision that x can never be equal to 2 or minus 2. So that's really the answer. It's not just x plus 2 over x minus 2. It's with these domain restrictions also. What else? Anything else you want to go over, Cole?
I can't really think of anything.
Okay. Well, you're coming down the home stretch, aren't you?
Yeah.
So you're not learning any new material? It's just old material that you're reviewing?
We were just going over complex hyperbolic functions, but
Well,
With functions, but that was it.
here's the parent function for a hyperbolic function. That looks like this.
Yep.
In other words, the x-axis and the y-axis are your vertical and horizontal asymptotes. And that's the simplest one. But whenever you have something, let's say that it's 1 minus x over x plus 2. That's hyperbolic in nature. Even though it does not result in a 1 over x, it's still going to be hyperbolic in nature. Because all I have to do to graph that is figure out where my vertical asymptote is, where my horizontal asymptote is, graph either in the first and third or the second and fourth, figure out which one's correct, and my answer. So rational quotients are actually rather easy. You just have to always start with vertical asymptotes, horizontal asymptotes, and factoring. Now, let me just test you real quick. What would the vertical asymptote on this be?
Vertical, -2. Oh.
How about horizontal?
Horizontal would be 1.
It's the ratio.
-1. Sorry.
Yeah, the ratio of the coefficients. So the horizontal is at -1. Now I know I'm either there, or second and fourth. It's always the way it works. Plug in a value, a really easy value for x to figure out which one you have. It's a good value for x.
-1.
How about 0? 0 is always a great value for x because it makes it so easy to, what should y be when x is 0? 1/2, right? Well, here's x of 0. Is it my y, is it my black function or my red function?
It's your black function.
It's the black, exactly. So that's all you have to do is plug in one value for x to determine whether it's the black or the red. And you're going to always know because it's either going to be above this horizontal asymptote or below it. Never going to be right on it. That's why it's an asymptote. Never goes on that, okay? So that's pretty much the way to do them. Any one. Draw your grid first, then know it's hyperbolic in nature. As long as you can figure out your horizontal and your vertical asymptotes, you're fine. What's the horizontal asymptote for this function?
Y equals 3.
What's the horizontal asymptote for that function?
Y equals 0.
What's the horizontal asymptote for that function?
There's no horizontal asymptote.
Very good. It's a slant asymptote. In other words, when the power of the numerator is exactly 1 greater than the power of the denominator, you do the division. And the division produces a linear result. And so you end up with a line that is called a slant or oblique asymptote. Whatever your linear result of that is, and discard the remainder. You don't care about the remainder. You just care about the linear factor. That's probably not going to be something you're going to get a lot of on your test. So as long as you know what it is when they're equal or when the bottom is bigger than the top, that's the most important thing. All right. Anything else at all, Cole? I feel bad I missed our appointment. I never miss an appointment. Of 100 missed appointments a year, it's always 99 the students, 1 for me. Last week was the 1 for me. I apologize.
It's all good.
Make sure, here, let's look at the schedule here, because I know you're going to want appointments going into finals. And I've got you down every Monday at 3:30, yeah, up through May 22nd. And I don't think you probably need one after that, right? Your final is before May 29th?
Yeah. It's May 24th.
Okay, let me cancel the one on the 29th so I'll know what your schedule is. And I will talk to you next Monday. By all means, if I do not talk to you, call me.
Gotcha.
If nothing else, it'll wake me up. But okay. I will talk to you next Monday at 3:30.
All right, talk to you then.
All right, Cole. Bye-bye.